Hey guys, Paul with Diode Dynamics here at our St. Louis facility. I'm going to show you around both of our buildings and give you a look at how we design, manufacture, and distribute the various lighting products you see online. Let's come on in and take a look. Now, we're here in our showroom at 4200 Shoreline. We moved here in 2014 and we're open to the public. You can stop by during working hours. That's 9 to 5, Monday through Friday. And as you can see, we've got all kinds of lights on the wall. Got some apparel here. You can stop in and pick up anything you might be looking for. We've also got a pretty cool display showing off a couple of our lights, some halos installed, some backlit wall. We really have it all here at the showroom, ready for pickup anytime. So if you're local, stop on by. Now we're going to take a look at our office area where we do all kinds of marketing, service, and sales work. All right. Hey guys, so this is our sales and service team in here. Now we've got a whole team of guys who are really well trained to help out with any type of concern, question, whether it's installation or just placing an order online. These guys are going to handle it and help you out. So pretty straightforward here, but call us anytime. Again, 9 through 5, Monday through Friday, Central Time, and we'll help you out. Now we're going to take a quick look in our studio. Now we're in our studio area, and as you can see, we've got all of our SEMA trade show booths on display. We have an open house every year where we kind of show these off, get it ready. Anybody local can stop by and check it out if you can't make the trip out to Vegas. So we've got all those set up here, but as you can see, the rest of this area is devoted to kind of a garage setup where we do actual installs on all kinds of vehicles, cars, and trucks. You can check those out online as well. So many install videos our team does. Every single week we got a new vehicle in here that we're testing out in one way or another. Now we're gonna head over to Building 2. All right, this is the place where the magic happens, our engineering offices. Let's take a look. So our engineering team works in here and we do all kinds of work to do our optic design, our electrical design. We design all of our own circuit boards, the drivers, the LEDs, all of that in-house. We have housings, heat sinks, castings, all kinds of stuff like that too. So some of this we can see, a lot of it happens on the computer. Let's first of all take a look in our mechanical engineering office and we'll see what he's up to. So over here in mechanical engineering, as I mentioned, we're designing all kinds of parts all the time. So what are you guys working on right now?
The F-150.
So we got a cool bracket here to hold our new work light in the F-150 application. This is F-150, F-250. You can see this is actually 3D printed that we're gonna check out. Holding in there nicely. Looking good, guys. So all kinds of stuff designed here, both the products and brackets and mounting solutions and all kinds of stuff, whether we have to do a screw design or some type of hardware or even just the wire harnesses, everything gets designed, drawn up by our team here. Let's take a look at the electrical side of things. Now, back over in our electrical lab, you can see one thing we have in here is actually for mechanical use. So this is a roamer coordinate measuring machine or a scanning arm. It's got a laser scanner and a couple probes, and our mechanical team really makes use of that in order to scan in vehicle dimensions, all that geometry, make sure everything works perfectly. So we advertise a lot, CAD designs, fits perfectly, and that's how we can confirm that it will, because we've done the scanning and we know when it goes on that vehicle, it'll work. Of course, we make those prototypes, we test them out ourselves as well on that vehicle. Now the rest of this area is our electrical lab. As you can see, all kinds of different components happening here. We've got a couple headlights always strewn about somewhere, but we're always designing new products, new drivers for our LEDs, new iterations, maybe adding features to some products. So all kinds of stuff happening all the time. You can see here we've got some new driver layout. So no matter what it is, we'll always get one of them off our production line, bring it to engineering, make sure everything's working properly, and do all that extra testing. Now we're going to take a quick peek over here because it's where our 3D printer is operating. So as you can see over here, we've got our first 3D printer, which is more of a display right now. Got a little half a car model sitting there. But we still use that for some of our cheaper, quick parts we need to do. Otherwise, this is our main workhorse, the Connex 500 Stratasys printer. We've actually got another part printing in there, a new work light bracket. That's going to be for the Tundra and older F-150s. everything gets 3D printed, and we're going to do those prototypes before we do any type of production of our products. So it's really important to get those prototypes done, check that fitment, make sure it's all perfect before we go to have it molded. Let's head this way to go to our validation room. All right, so in this room, we've got a number of different machines that we use to test things out. And we're gonna be testing to the minimum environmental requirement for on-road use, that's SAE J575. So behind me, first of all, we've got an age test shelf. That's for another test standard that's used for LEDs now. Essentially, we have to let things run for months and months and years at a time. We'll test the lumen output, and then we'll come back 6 months later, test it again. We want to make sure the lumen output stays the same for months and months of use. If it degrades too quickly, it's not going to be too good after a few years on the vehicle. So we want to leave them on the age test shelf, keep testing it, make sure we hit those standards. Now for the environmental test standards, there's a couple of key tests, and there's a couple small tools, but the big tools are right here. So the first one is this water spray test. So we're going to have a part mounted in the middle here, and then it'll rotate around and spray our lamp, our work light, our side marker, whatever it is, with that high pressure water spray. From there, we have our environmental chamber. So this is going to go from -40°C all the way to 85°C. That's about 180 Fahrenheit. So we're going to get it really cold, make sure it'll work well up in Alaska, and then really hot, make sure on a hot day in an engine bay it's going to keep working. Again, that's following the prescribed standard, SAE J575. Couple hours at each level, it's going to go through a whole cycle. So we can stress our products in that way, make sure that they're going to either dim down if it gets too hot, or just keep working at that very high temperature. Most products are not designed that way. They're only designed for room temperature. We know our LEDs are going to last because we put them in a machine like this. Finally, we've got a salt spray test, and this is going to basically generate a saltwater fog, and it'll really rust and corrode, unprotected metal very quickly. So we do a lot of hardware design and brackets for our products. We want to throw it in there, make sure the finish holds up, make sure that it is stainless, whatever we might specify, to make sure it can pass this test and it won't corrode on the exterior of the vehicle. Again, making sure we're meeting that 575 standard from SAE. Now, over here is our last piece of equipment for that J575 test, and that's a vibration table. So pretty small, but we usually have a headlamp mounted on there. That bulb will be inserted, and then we can test to make sure we're not putting too much strain on the original bulb retainers, sockets. Everything's going to stay in place. We also will completely assemble our bracket setups. Do we need, a lock washer, one with flans, a serrated washer, a serrated nut, in order to hold everything in place with all that vibration? This machine really shakes things pretty hard, again, to a prescribed standard, in order to tell us if we're doing good. Now, in the room right here, you can see through the window, we've got an electrical test. Now that's going to be testing the electrical toughness of the products. And what we have is a very basic setup, but it's real specific for automotive. When LEDs die after a year or two on the vehicle, it's not because they got too hot, and usually it's not because they fell apart. It's because there's electrical spikes happening all the time. That's from the alternator to the fan. Any inductive loads on the vehicle electrical system is going to spike voltage into those LEDs. And if they're not protected, after a year or two, they might start flickering and then go out. So again, if you've had an LED that's gone out after 2 years randomly, that's probably why. All of our products are now designed with protection in those circuits, and we can confirm that by basically hitting them over and over with those voltage spikes. So we know that they're going to be protected on vehicle. So a couple of hundred of those pulses now translates to years of use on the road. We know they'll be okay. Now in front of me here, this big ball is one of our first lighting test pieces of equipment that we purchased as a company. And that's because it's really important. This is how we're going to measure lumens and the color of light. So the way this works, it's an integrating sphere. So we're going to open it up. As you can see, the whole inside is this white reflective material. We'll put a bulb or a light source in the center here and shine it. It's going to bounce around or integrate on all the surfaces inside here. And then we can measure it at one point and bring it into the computer and equipment. Using geometry, at one point, we can calculate the total light hitting all the surfaces inside, and that's how we get an actual true measurement of the lumen output. You'll see a lot of lumen measurements online, but very few sellers and manufacturers use equipment like this in-house. By doing this, we can test every single batch of products that we produce or import, and we can make sure the lumen measurements are accurate, instead of a calculated or raw lumen figure you might see elsewhere that's usually really inflated. Now, this also lets us test the color of the light, and that's important because every single batch of raw LEDs we bring in, we'll test a couple of those, and that allows us to make sure no matter what type of product it is, a work light, a light bar, a LED board, a halo, or a bulb, they'll all match perfectly with that white color. There's a lot of misconceptions about a 5000K, 6000K, or 8000K white light because you hear people describe it, and it is very specific when you get down to it. We test it, so all our products are going to be that 6000K real clean, white, cool white, or if we specify 4000 or 3000K warm white, we know we can test to that and hold those parameters. That way, if you buy a white light from us, it'll match the rest of the lights from our company instead of purplish or greenish colors. So that's pretty important. We have one more piece of lighting test equipment, which is a little bit bigger, so we're gonna head over to our warehouse again to check that out. All right, so what we're looking at in this room, you can see it's a big warehouse, but this tunnel is gonna go all the way down into the right of this warehouse, and it's gonna be about 50 feet long. So here's the entrance, and what we have here is a goniometer. So it's in this light tunnel. We're running a test right now, so I hope they don't get too mad. I'm gonna pause this test real quick. So we're gonna pause that, and we'll take a quick peek in. So I'm gonna flip on the lights here. So what we're doing is actually testing the beam pattern of a headlamp or any type of light that we have, work lights, light bars, anything, projector units, whatever it might be. This whole setup here is gonna be the power supply and the control unit. Let's take a look in so you can get an idea of what we're talking about. So we're in here with all these curtains set up. That's to absorb the light. And that's because the way this is gonna work is we're gonna have a headlight or just a work light or something mounted to this pedestal here. And then we're gonna shine all the way to the other end. So I don't know if you can see that at all the way down here, but there will be a sensor at the other end of this tunnel. So that sensor is gonna stay in one spot. Then we're gonna move this headlight left and right, up and down, and that way we can map out the entire beam pattern. And that's the way we can test to make sure that the actual beam pattern output is, again, meeting those SAE requirements for what we need, whether that's a low beam, high beam, even turn signals, DRLs, and even side markers. They all require specific amounts of light in specific directions. So our integrating sphere was used to test the overall omnidirectional output, light emitting in all directions from bulbs. This is how we're gonna test headlights. Anything that's focusing the light forward will have to go to the light tunnel. So the last tool we need for engineering is a plain old garage. Let's go take a look. All right, so this is our engineering garage. Totally different than our marketing area. This is only used by our engineers. And that's because these days we have to test all kinds of products on the vehicles directly. It's not the good old days with this 12-volt batteries and relays. Now everything goes through vehicle computers. And we do a lot of products where we have it replacing DRL or turn signals or tapping into those lines. And that means we gotta tap it all in on the vehicle to make sure it works. Anything you buy from us, you can be assured that it's been tested on that application, so it'll work without any errors or any workarounds. We've got our F-150 here, which we brought to SEMA in 2017. Still looking great. Looks like we're probably doing some testing for that, probably the F-150 bracket that we just looked at. So in this garage too, we can also design up any type of production equipment we need. Got a laser engraver, router, sanding wheel, all kinds of stuff because we make a lot of jigs for production as well with our production engineer. So that wraps it up for engineering. Now it's time to check out our manufacturing. So coming out of the garage, we're headed right over to our receiving area. Now, just a couple tables, but this is really important for what we do because everything has to come in, be received, be accurate, be counted, be on the shelves so it's ready to use when we're good to go. We make over 300 different SKUs here, so it's all about how can we stay really flexible and stay very efficient with our production operations. And that's a large part to do with our organization. So from there, things go into our raw components warehouse. As you can see, we've got all kinds of castings, housings, wire harnesses, all kinds of things that come in from our suppliers and get stored here until they're ready to use. We keep about as much raw materials as we do finished goods on hand so we can respond to demand very quickly. From here, we're gonna head to our assembly area. All right, so we've gone around and we're starting up at the front of our production operation. All of our production is gonna start with the circuit board assembly, which is what you see in this room. So let's take a look. So in here, we've got our SMT line. That stands for Surface Mount Technology. That's the newer type of electronics assembly, and it's how all products are made. So your cell phone, a microwave, anything is gonna rely on circuit boards made with SMT technology. So it all starts with circuit boards over here. So let's head over. Again, we design all of the circuit boards we have and that we use here. So whether it's a driver board or an LED board, we've got all kinds of different shapes. You can see these are the boards going into our side markers lined up on a panel like this. And then we have a lot of these driver boards as well, just in these rectangles. We'll break them apart and put them into the products one at a time. So we've got the bare circuit boards in stock here, and we also need the components. So you can see all of our component inventory. We've got resistors, capacitors, tons of different LEDs. We carry millions of different components at any given time, so we're ready to go. From there, we're gonna go to assembly. So the first step is gonna be this machine here. This is a screen printer, so this is gonna apply solder paste or little ground up balls of solder onto those circuit boards. To do that properly, we need the right stencil. So you can see all the stencils here. We've got a 2013 Mustang RGBW stencil. You can see they're gonna have little cutouts where that solder paste is going to go straight through to the circuit board. So put that up. That gets loaded into this machine here, and the boards get fed in. So this machine is going to put that paste on. It'll have a squeegee coming across. It's just like doing it on a t-shirt or something. It'll come down, really high pressure, push it through. At every step, it's going to have vision recognition to make sure everything is perfectly aligned as well. Now, once the circuit board has solder paste on it, it'll go to our chip shooter or pick and place machine. Now, this is a brand new Europlacer XP2 Plus, so it's got 2 opposing turret heads on it. So this does very fast placement. You can see we're running a little bit of a slower board right now, but this can go anywhere from about 6,000 components per hour all the way up to about 25,000 for really optimized designs. Every component it places, this machine can test it. It'll test, the voltage, capacitance, resistance through the component before it starts placing it. That way we can make sure that every component is going down in the exact right place. Very highly accurate, very fast. We're very pleased with this investment. So once those are on the circuit board, it'll be done and it'll come out the other side. And the next step is going to be putting it in an oven. So that's going to heat up that solder paste and it'll bond everything together. So it'll ramp up, melt the solder, bond everything, and then cool down on the other side. You can see it's pretty long, so we can fit quite a few circuit boards in there. You can see there's one that just got done here. So we've got one of those driver boards with all the components assembled with it. And we can go ahead and put it in the oven after it gets inspected here. Now, you'll notice the floor in here is white as well, and that's because it's an ESD tile. So we laid out this flooring ourselves. It's conductive. That keeps everything protected against ESD during the production process. Now, at the other end here, the boards are going to come out and be essentially finished. But before we release them, we're going to want to inspect them. And that's what we got this machine here for. AOI stands for Automated Optical Inspection. So instead of looking at the boards, we can run it through this machine, and it'll pull up and go through a whole series of different photos. Looks like we're programming a board in here. It'll take all kinds of different photos of the boards being tested and give us any type of warnings for misaligned components. It'll tell us if it's the wrong component. It can read the different values off those components as well. So it's a great way to quickly and accurately test out all the boards to make sure everything is placed correctly. We'll also do some functional tests. You can see here's our driver test setup, this is a board of 9 drivers, so there's 9 bulbs here. We'll just push it down onto here. Can you do one? Cool, so we can check this out. So Brett here is our SMT lead, and he'll push it down here, quickly test, light up 9 bulbs at once, pretty bright. You can see he's got the shades on, and that'll allow us to quickly do a functional test on those as well before we go to assembly. Now, the last step for some of our boards, you can see here, is our coating. So our SMT team is going to do this coating process where we use a pair of these CNC dispensing machines. It'll run a preset program, and that's what will add the coating to our halo type products. So you can see here, got one of our WRXC lights. One of them has just the LEDs on it, and this one has the coating applied. It'll give it a really solid appearance, so it's just one solid bar of light all the way around and hides those LEDs when it's turned off. So, a proprietary process. We developed this coating directly with a company in Wisconsin. We're really happy to be doing this. It's a silicone-based material that's really durable. From there, our boards are going to go over to assembly. So let's head over there. We're going to take a quick peek in our stock room here. You can see we've got quite a few different boards kind of as a buffer. So because our SMT team works at a slightly different calendar than assembly, we've got some boards here that are just waiting to be assembled. Got all kinds of tools here ready to go too. So no shortage of good tools around here. So we always have what we need. So the first part of assembly we're going to take a look at is our drivers. So you can see some staging areas here, but then a lot of those boards are going to go to our driver production cell. So that's going to include those rectangular shaped boards that I mentioned, and most of the time with drivers we're going to be filling them up with epoxy in a process called potting. So that's what this machine is here. You can see our team here is adding wire leads to those circuit boards, and then they're going to use this here to fill up those housings with that potting material. So you can see the result is totally filled and encapsulated products. That'll cure over 24 hours, and once it's done, it'll be totally protected against any type of moisture or vibration or anything. It's not the cheapest way to go about it, but it's the most reliable way to make sure we're never going to have any issues with moisture on these drivers that can be mounted externally. So from there, our next production cell to look at is our SL1 and SLF. This is one of our most popular products, and we got it laid out here. You can see it all around. We've got certain steps at every process. Essentially, we're going to start with our circuit board. So if we take a look over here, our driver team is going to get these guys ready to go. So it's the driver all ready to go with the LED and the fan added. So we've assembled the LED, got the driver ready. And then the first step here, we're going to be continuing to assemble that LED onto there. So we've got those ready to go. Over to here, we're starting the assembly process. We've got our castings laid out. Those castings have the thermal transfer material already applied. So that'll be assembled. The next step is adding that fitment ring. We got to make sure that's correct. So at this step, we're going to be testing each one of those as well to make sure it lights up. It'll only light up if the fitment ring is correct for that size bulb. So we do a real good job with our organization, but suppliers, they might accidentally put the wrong fitment ring in the wrong bag. So we have to test that out. We put as many quality checks in there at every step of the process as possible. Finally, you can see as they're getting done, they're getting packaged up with some install guides here, directly in that blister. Last final visual inspection here, and then they're going to be packaged up and out the door. So that's our SL1 and SLF production line here. Next, we're going to take a quick look at our general assembly. This is where we do a lot of our wire attachment for just general LEDs. Your tail is turned, smart tap, any of those power control modules. Looks like today we're just getting some organization done on some anti-flicker modules. So getting those lined up, ready to go for potting over here, just a little bit of extra workspace. One thing you can check out over here is we've got all of our test jigs, so you can see for every one of the products we make, we'll design one of these test boxes and put some LEDs in there for the testers. Sometimes they're too bright, so we'll cover them up. But you can see every product we make has a test box. This is TJ41 skewed for maintenance, everything ready to go. We always want to make sure that test box and test plan is ready when we're ready to make that product. So when we design a new product, we also design a test box, design a test plan. Make sure that when we go to make it, we can test it out and get the quality we need. You can see over here, we've got kind of a wiring harness area as well. All kinds of different heat shrink, lots of different wire. We do produce some of our wiring harnesses in-house when we can. Next step we're going to take a look at is our final packaging. So for products that don't have the inline test in the production line, we're going to run them through a 4-hour test. This includes our demon eyes, our halos, our LED boards. All of those are going to be a full 4-hour test. So when you get a product from us, you can be assured that it has been tested for that full 4-hour procedure. So you can see we've got all kinds of things lined up. Close to the end of the day here, so I think we're packing up. You can see quite a few, what are these? Always on modules, just getting packaged up here as well. So we do quite a bit of packaging in this area. So you can see bubble wrap, and then over on this side, all the install guides. So our marketing team does a great job getting all these together. Some companies will just tell you to go online and find the instructions. I don't know about you, but when I'm going to install it in my car, I want to read those instructions. So we have those available, no matter what the product is, all the info, the wiring information that you might need, again, included with your order. Now, the last area of assembly that we have here is our side marker cell. So we're just starting to produce some of those small lamps. We're hoping to ramp it up, but for now, we've got these ultrasonic welders that we use to assemble our side markers. The way those work is that it's a very, very high frequency ultrasonic pitch that's run through a horn, comes down between two pieces of plastic and welds those pieces of plastic together. This is how taillights and side markers are assembled. So we've got 2 here, 1 left, 1 right. Our team is going to be doing the assembly. So first they're going to wire these together here. They're doing some Mustang side markers right now. And then we're set up, ready to go with that welding. As soon as they have enough ready, they'll go ahead and start welding those up. These are in enclosures because it does get pretty loud. When it's welding, it'll make kind of a shrieking sound. So door closes, weld happens, door comes back up. That way we can have it all still in line. These get packaged up and straight out the door from here. Again, there is a final test that occurs. Everything gets tested before it goes out the door. But that wraps it up for our assembly team. Finally, things are going to head out the door to you over in our shipping warehouse. So as you can see, we just were about 20 feet away from our production area, and this is where things are going to be headed out the door directly to you. So a lot of the time, we can be starting to assemble some circuit boards, and it goes through assembly and it's shipped out the door the same exact day. We're really happy with the efficiency and the turnaround time we can achieve to meet customer demand these days. So pretty straightforward setup, some shipping stations. We try to stick to very efficient procedures, but we do have quite a bit in stock. Let's take a quick look over here. So you can see we do carry quite a bit on hand these days. All kinds of different bulbs here. We've got light bars, we've got cases and cases of different SL1 bulbs, we've got halos up there, Ram halos, Camaro DRL boards, all kinds of good stuff. And that's how we're able to fulfill orders same day in most cases. So we have a very low back order rate at this point. Our team does a great job with our new ERP, MRP software for planning, and with that turnaround time, getting things received accurately, straight through production, shipped out accurately to you. We can provide you that good service to get you some quality, made in USA products. That's going to do it for us here at Diode. I appreciate you taking some time to check out our facility. If you have any questions, please feel free to comment and we'd be happy to talk to you. Thanks again.